Picture a scientist. What image pops into your mind? For many, it will be the wild-haired Albert Einstein, late in life with a wrinkled face, perhaps with his tongue sticking out. Or maybe Isaac Newton in his formal regalia and 18th century wig. But these images are of the great scientists many years after their seminal works. The alleged comedy show The Big Bang Theory has shown us that science is a young person's game, and although the awkwardness that is played for laughs is an unhelpful scientific stereotype, it is correct that most scientists make their biggest breakthroughs when young. Indeed, it's important to remember that Einstein was only 26 during his miraculous year. Isaac Newton was also a young man when he had his greatest insights into nature, and in 1666, he was just 23. He'd already proved himself as precocious and had been studying at the University of Cambridge, but this year was to be a year like no other. The Black Death had returned again to Britain. The bubonic plague first raged across Europe in the 14th century, but it had never really gone away. For centuries, it resurged and cut a swathe through European populations. With its re-arrival in 1666, people had fled the cities for the relative safety of the countryside, and Isaac Newton left Cambridge for his family farm in the village of Woolsthorpe in Lincolnshire. As death stalked the land, Newton found solace under his famous apple tree, and his mind turned to unraveling the secrets of the universe. We've already met Newton's ideas of space and time, but let's look at time again. With his equations of motion, Newton could calculate how things changed with time, and time could be neatly cleaved into three distinct pieces: a past that had gone, a future that is yet to come, and an instant that is now. Reality, it appeared, existed at this unique instant of now, a precise and exact now, evolving from its state in the past to the present, and we can calculate what will happen on into the future. But Newton's equations are purely deterministic, and so if we had perfect knowledge at any time, we should be able to calculate the exact state of the universe at any other instant. And so this raises an interesting question. In a Newtonian universe, has the past really gone? Is the future really unknown and yet to come? In some sense, the realities of the past, present, and future all exist, and the instance of now is just sliding through this already complete history, with us just experiencing a moment of reality. This idea returned with a vengeance in Einstein's theory of relativity. Instead of just a background, space and time became central to the story, with each fundamental particle tracing out a distinct path, its world line, through these four dimensions. And like Newton, Einstein's universe is purely deterministic, with past, present, and future all existing. This came to be known as the block universe, and once again, the mathematics is pretty clear on something quite bizarre. The equations of relativity are unequivocal. Einstein's universe is a block universe. With perfect knowledge, there is no mystery about the future, as it can be calculated from now. In fact, Einstein's equations don't just define what now is, you have to define when now is. There is nothing special about now in Einstein's universe. Of course, the block universe raises some uncomfortable questions. Questions around free will. The ability to choose between possible options seems innately human, but in the block universe, this is just an illusion, as the future is already written. And the block universe also has even bigger consequences that stray back into science fiction. If the past and future are out there in the block universe, could we ever reach them? Out there, Da Vincian dinosaurs, every creature and everything that will ever be. And maybe there are convoluted space-time paths that mean we can experience them in our now. But the issue is that the block universe just doesn't feel real. Surely the future is unknown and yet to come. And so many tried to look beyond the raw theories of Einstein to provide the answer. Eventually, the probabilistic nature of quantum mechanics appeared to show that Einstein could not be correct. the future being written from the possible outcomes of quantum questions. And so the picture that emerges from this compromise is that the universe is a block universe up to a point, and that point is now. Now is constantly being constructed as quantum questions are answered. Now adds another sheet of reality to the block universe, unfolding an unknown future in front of us, with the past solidified into the block behind us. And interestingly, this is the picture offered by loop quantum gravity, one of the contestants for the theory of everything. Within this theory, space and time are constantly being weaved from fundamental loops. Now is the edge of the weave, the past is the tapestry, and the future is the unknown ahead. Our reality, our now, would be at the busy edge of the construction of space and time. This gives you pause. Is the apple you see now the same apple you saw just a moment ago? Are its time, space, and fundamental constituents constantly being knitted from the ultimate fundamental? Are you and the apple being rewritten at every single instant you experience? Deconstruction after deconstruction, your grip on reality seems to be definitely slipping. And so you settle on a simpler question. Where is reality? Maybe reality is the block universe, and that's all there is. Maybe free will is an illusion. Or maybe loop quantum gravity is correct, and reality exists as an instant of an unfolding universe. But what if there is something much deeper underlying reality? Something that is not physical? What if, at the bottom, reality is nothing but numbers? This idea isn't as strange as you might expect. Indeed, it reflects our understanding of the workings of the fundamental universe. Written at the heart of all physical laws is the notion of information and information processing. Just what do the laws of physics do? Well, they take what we know about a particular situation, the information of that situation, such as the location and velocity of a ball flying through the air, and process it into information of that scenario into the future. This is probably most apparent in the rules of quantum mechanics, where the information of a scenario is encoded into the wave function. The rules of the quantum evolve the wave function, the information, into the future. Numbers are churned into new numbers as the laws of physics are played out. This all might sound a little esoteric, but by the mid-20th century, strong links had emerged between information and thermodynamics, as it was realized the effort to process a signal requires energy. A computer has to expend energy to flip a bit from a 1 to a 0 or vice versa, as does your brain as you process even the simplest of thoughts. And all of this has led some to propose that everything is really just information processing, that there is no fundamental difference between the processing of information on a computer or the processing of information in your mind, or the processing of physical information that underpins reality. This is the foundation of what is known as the simulation hypothesis. This hypothesis states that our thoughts, memories, and all our experiences are nothing but computations. This is deeper than the idea of a brain in a vat that we encountered previously, as there is no physical brain. In fact, in our reality, there would be nothing physical at all. Of course, the simulation hypothesis raises an immediate question. Just where would these computations be taking place? Perhaps they exist in a higher reality, a physical domain that we can know nothing about. But what would be the goals of our simulated reality? Why would our creators create us? What if we are little more than characters in a game of The Sims? But that's not all. What if the simulation was not created for us? What if it was constructed to explore other aspects of synthetic universes, and we are nothing but an unexpected side effect? What if the creators know nothing about our existence, and care even less? Of course, we can argue about all these questions, for the answers might always elude us. But here on Earth, physicists do generate synthetic universes with the goal of understanding our reality. and also explore other seemingly hypothetical universes where the laws of physics are different. Maybe one day, with powerful enough computers, conscious creations may inhabit our synthetic worlds. But even if we are living in a simulated universe, and our reality is completely synthetic, surely our creators would inhabit a real reality, a physical reality. And so have we just pushed the problem upwards, or is it turtles all the way down? We come to this conclusion because we imagine that there must be a physical computer, a device that carries out the calculations that construct our reality and synthesize our universe. But what if there isn't? What if there is no physical basis for reality? What if there are only calculations? This is the idea of the mathematical universe. The lead proponent of the mathematical universe is Swedish-born Max Tegmark. In his earlier research, he focused on the challenges of modern cosmology, but eventually he turned his attention to some of the biggest questions we have. His mathematical universe is similar to that of a simulation hypothesis universe, but without the need for a physical computer to do the computations. And so, where would these calculations be performed? What would be performing them? Surely you need a computer to compute. But being truly fundamental means that these mathematics just exist, and there would be no real answer to where they came from or where they exist. Intriguingly, Tegmark's mathematical universe is actually a multiverse, containing not only our universe but all possible universes. In the growing maelstrom of mathematical calculations, there is not only our particular reality, but all possible realities, each defined by distinct mathematical structures of their own. Across this multiverse, there should be mathematics similar to our own, with multiple versions of you, whatever you really are, out there. Of course, there will be other universes which are quite different to our own, different in terms of the strengths of the fundamental forces or dimensions of space and time. The library of possible mathematics is immense, possibly infinite, and definitely much larger than the subset of mathematical structures we use to describe our cosmos. So out there, in the sea of fundamental mathematics, there could be much, much more. Not only universes that we've not dreamt of, but many we could never dream of. And one last horror, one prospect of reality exists in this mathematical universe, and it is tied to infinity. Every so often, within the infinite sea of calculations, just the right calculations will randomly come together. These calculations will look just like your mind, a mind filled with your memories and reality. In just an instant, you will be created, maybe considering an apple. Of course, to this brand new mind with all its memories, everything seems completely normal. They remember the big events from their lives and picking the apple from the tree. But the existence of this mind is only temporary, only a mathematical fluctuation. As quickly as the mathematical structure of this mind came into being, it vanishes back into the wash. This consciousness, with experiences of reality as real as ours, is doomed to disappear in an instant. And these relatively tiny fluctuations in the mathematics would massively outweigh the likelihood of our entire cosmos. And so, how do you know that you are not one of these minds that will vanish in a moment? How do you know that anything you think is real was there a moment ago? How do you know that you are not about to wink out of existence? By now you might be thinking, well, this is ridiculous. I know that I'm not a mathematical structure, and I remember what has happened to me. There's no chance that I'm a temporary existence. I know that I am truly real. But unfortunately, getting rid of the mathematical universe does not fix the problem. It is believed that our cosmos has an infinite amount of time ahead of us. And for this infinity, the universe is going to be cold and empty, long after the last star has died and the final black hole has evaporated into the background. And so it might seem that we would reach the end of the story of the universe, as not a lot will happen in our future empty cosmos. Surely it will be a quiet, uneventful place. But this future universe might not be as dead and buried as it might seem. And to understand this, we need to explore one of the most misunderstood concepts in physics: entropy. Ludwig Boltzmann was one of the most insightful minds of 19th century science. Before it was widely accepted, he was a supporter of the atomic hypothesis, the idea that at the smallest level matter is made of indivisible atoms, and he recast the laws of energy flow, thermodynamics, in terms of the motion of these indivisible atoms. Boltzmann's view attracted criticism from the scientific greats of his time, but shortly before his death in 1906, direct evidence for atoms began to appear. In pondering the realm of atoms, Boltzmann wondered how they could be arranged. Think about the air around you. Atoms of nitrogen, oxygen and carbon bound into myriad molecules. These molecules are whizzing about, colliding with each other, with the walls, and with you. At every moment, every configuration of atoms and molecules seems completely indistinguishable. But experience does tell us that the atoms are unlikely to spontaneously gather in one corner of the room. And if we started with all the atoms of air in one corner, they would rapidly spread out and fill the room. Boltzmann showed that this difference is simply a matter of statistics, that specific atomic configurations evolve into more general configurations. And this evolution of configurations from specific to general is known as the growth of entropy, and it has become one of the most fundamental rules in the cosmos. And these ideas of specific to general atomic configurations can be thought of another way, that order eventually gives way to disorder. Let's try to understand this in terms of energy. The total energy in any particular scenario must remain constant. This is another of the rules of thermodynamics. But not all energy is the same. Some of it is useful and some of it is not. The growth of entropy means that useful energy is degraded into useless energy. Imagine you have a cylinder of compressed air. This scenario is a little like the situation where you have all your air in the corner of the room. This highly specific case is said to have low entropy as it has lots of useful energy. And to tap this energy, all you have to do is open the valve. The rush of air from the valve can be used to spin a wheel, and this spinning wheel can be used to do some useful work, such as generate an electric current. But eventually, when all the pressures have equalized, the rush of air stops, the wheel stops spinning, and no more useful energy can be extracted. This is true of every physical process, with useful energy constantly degraded into useless energy. Indeed, your body is constantly fighting the growth of entropy, but to do so, you need a supply of concentrated energy from the food you eat, which you process into more useless energy in the form of waste and an infrared glow. You are doing your part in constantly increasing the entropy of the universe. Entropy has been rising since the dawn of time, with useful energy constantly diminishing, and the question of why the universe was born with extremely low entropy, so lots of useful energy, is still unanswered. But eventually, in the far distant future, there will be no useful energy left in the cosmos, and the universe will have entered the state of maximum entropy. And so, as we have seen before, it appears that we have reached the end of our story. For what can happen in this maximum entropy cosmos with no useful energy available? But remember, the rules of thermodynamics laid out by Boltzmann are statistical in nature, and in these statistics, bound by probabilities, even the seemingly impossible can eventually happen. Perhaps the air in your room could spontaneously gather into a single corner, or billiard balls could rearrange into their starting formation. Boltzmann said that whilst this is highly improbable, if we wait long enough, it must happen. How long might be a very long time, much longer than the current age of the universe, but if there is one thing the future cosmos will have in abundance, it is time. In the ultimate disordered state of the future universe, order will sometimes spontaneously arise. Every so often, the laws of thermodynamics and quantum mechanics will fluctuate. These fluctuations will in general bring some particles into being before they fluctuate away again, the universe going back to being quiet and uneventful. But even rarer than every so often, fluctuations will bring more substantial things into being. Vanishingly rarely, the complexity of a human mind will fluctuate into existence. Usually, these will be a blank slate, not thinking a single thought before vanishing again. But rarer still, a mind with memories and experiences will occur. These ethereal minds are known as Boltzmann brains and are extremely rare events, but with infinite time available, they will appear again and again and again. And over again, even your exact consciousness will pop into existence. Your consciousness, with all of your memories and experiences, an infinite number of times. And so, picking one of these at random, you are much more likely to be a Boltzmann's brain in a cold, dead universe than a physical, fleshy human enjoying a green, ripe apple. You, the mind watching this video, temporary. Your existence simply a fluctuation. In an instant, you will be gone. Are you sure that you have not just popped into existence and are about to disappear? Are you sure you are still here? Yes, at least for now. And so for one final time, your eyes settle on the solitary apple. The apple that sent you on this journey looking for the nature of reality. Your mind flashes across all the versions of reality you encountered in your dozing, from the forms of Plato through the weird world of quantum mechanics, across block universes, and in and out of holographic cosmoses. But clarity returns as your stomach starts to rumble. And again, you focus on the apple. You reach out and pick it up, feeling the smoothness of its skin in your hand. You take a bite. You've been watching the entire history of the universe. Don't forget to like and subscribe and leave us a comment to tell us what you think. Thanks for watching, and we'll see you next time.